Hello and welcome to this Unreal Engine tutorial. Today I'm going to show you how to render everything that is on your screen onto a render target. This is for still frames, so no like live feed of everything that's going on. Now there are a few caveats with this. Let me just show it to you. So if I hit one button, it will update whatever is on my frame and put it onto a render target, this render target. And you can then put the render target into a texture sample in your material, for example. Either that, or you can use it as a UI image, like here. So, as you can see, if I hit the button a few times, the frame time spike. So if you look at this line here, the yellow line, which determines your frame time, you see that it spikes quite a lot. So we're going from like 8.3 milliseconds to more than 10. So yeah, it's quite the expensive operation, but there's some use to it. So let's say you want to do a camera, like a Polaroid in-game. You could just simply use this method and get everything that's on the screen without any UI. As you can see, the UMG image that I have here is not being rendered into the render target. Yeah, so you could like do this and then serialize the data and save it somewhere. That's all theoretically possible. Code is pretty simple, pretty short, so there's not much to it. Yeah, so I guess we'll just jump in. Close this one. And then open Unreal Engine and create a new project. So yeah, as you can see, I've created a new game. Create a blank game with starter content and then just screen to RT, screen to render target. Okay, so I've included the starter content so that I can show you this with a bit more stuff in there. So this starter map, which has like a few example materials and also particle systems, things like that we will use. So before we start, we're just going to do some little default setup. Fill in your copyright notice. If you don't do this or do it after the fact, then a lot of files already have the non copyright notice line. We're also gonna create a game mode. Create a blueprints folder and create a new game mode base. I just call it blueprint bp_game mode. I'm also going to create a player controller. You can use any class, any actor class at least, I believe, for this. Yeah, player controller. And we're going to put our BP game mode within here, and we're also saying that the starter map will be our default startup map. Within our game mode, we'll specify our player controller. And then save and create a new C++ class. As I said, we're going to use a player controller, and we're going to reparent this in a second. So we'll create our screen RT PC. RT standing for render target in this case and not for ray tracing. So once this is done, we're going to do a few simple things. Yeah, just waiting for it to compile. Okay, so we're going to create a new render target. Come on. And I'll just call it RT underscore green. Nothing really that we need to set up within here. We can just keep this all by default. And we're going to reparent our player controller. So go class settings, then parent class. Change this one. In our case, we're going to use our screen. Render target player controller and hit save. Once we're within our new C++ class, the first thing we want to do is modify our build.cs. So what we really want is come on. We want to add 2 modules. We want to add the RHI, which stands for Rendering Hardware Interface, and the render core. These are both the modules that we need. They're both runtime modules, so they will run fine within your game. Okay, not public, protected. And what we're going to add is a variable and a function. So the variable will be our render target. So you render target texture, render target 2D pointer. I'll just call it render target. And also a u function. You don't need the second protected here, but I'll just keep it separated so it's easier readable. You have all your properties within one of those blocks, and then you have all your functions within one of these. So create a blueprint callable function, and I'll just call it screen to render target. You could theoretically also specify the render target as an attribute for this argument for this function, but we're just gonna use the default thing. Okay, so create the implementation, and yeah, so what we want to do is first check if our render target is valid. So if the render target is not valid, we're going to return. So if render target is a null pointer, we'll just return function and we'll do nothing because there's nothing for us to do. Next thing we want to do is get a pointer to a viewport, and we'll get that over our game instance. So we need to get the game instance, and from there get the game viewport client, and it has a pointer to viewport. So theoretically, you should probably also check if instance is valid, although this is probably always going to be valid. And also if the game viewport client is valid. It might not be on like a headless client. And here we'll just do an OR. And then we'll return. Also, if the viewport return. Save the first, right? Okay, next thing we want to do is get the size of our viewpoint. So for this we need an int point, which is essentially a vector with two values, two integer values. You get x and y. We'll just call this one viewport size, and we'll equal it to viewport get size xy. So let's just make this one const. Next thing we want to do is create a t-array with fcolor and call this one pixels. One value of fcolor will represent one pixel. It's a bit like a bitmap. Only that fcolor holds floats and not integers, I believe. Although I could be wrong. No, it holds integers. BGRA. Yeah, it's a linear color with the floats. Okay. That's more than alright. To read our pixels, we're just gonna do viewport and then read pixels. Now, you could do a read pixels pointer, but I don't know if there's much overhead using a t-array versus the C++ array. Read pixels and just do our array in there. Next thing we want to do is set up our render target. So render target, and we want to initialize with a custom format. So we can now define our format, but first of all, this function will also change the size of the render target. So in this case, we will do viewport size.x for the width and viewport size.y for the height. We're also gonna set our format. So this is from ePixel format, then pf underscore, and we're just gonna do red8, g8, b8, oops, and a8. So this is 8 bits for red, green, and blue, and because this is just a default enum, we can write it out without the enum in front. Force linear gamma, we'll just put this one to false. Since we're using sRGB, the gamma is not linear, I believe. Well, I tried it with true, and the render target got a lot brighter than it's supposed to be if you compare it to what you see on the screen. So yeah, there's that. We're also gonna tell our render target to use sRGB, so sRGB, which is a boolean, and we're gonna set this one to true. Then we'll tell the render target to update its internal resource. Great. So next thing we want to do is get a pointer to the internal resource. So the resource for this render target is a ftexture render target 2D resource pointer. Render target resource equals, you need to cast this one because the value is inherited from uTexture. So make sure to, in the static cast, you cast it to a pointer. And the resource. So if we go into the definition from this, this here will be in texture.h, which defines this class. View texture. Okay. So now we're gonna do qaRender. We have to do it within the every code that comes now has to be executed within the rendering thread. So not the game thread, but the rendering thread. If we don't do what comes next within the rendering thread, we'll crash the program. So that's also more or less the reason why it hitches every time we'll do this. Again, I would not recommend doing this on like tick. But yeah. So how we're going to do it, we're gonna qaRender command. And we're gonna give it a type name. So in this case, screen to render target, and then we're gonna give it a lambda function with a argument of frhi command list immediate. We'll need this one simply to know that this one will be executed immediately. We'll also need to capture a few things. So for one, we need to capture the viewport size, our pixels array, and our render target resource. Okay, so again, everything that is executed within here will be executed within the render thread. It's important to keep things within here as minimal as possible. If you do any like really big operations, you can block your whole rendering. You will halt the program essentially. So let's go. First of all, we need to tell our render target resource to initialize the dynamic rendering hardware interface, and need to get our texture, our texture data essentially from the resource. So the data is more or less RHI texture 2D, and we'll just call this one. They call it RHI texture 2D, so we'll call texture RHI, I think, within editor code. And then equals render target resource. And get texture RJ. Then we're going to define unsigned integer 32 bits. And we'll just call this one line size. They usually call it dest stride. We just can call it dest stride as well. But it's more or less just the size of one line. So if you have, I don't know, 3840 pixels in one line, then you have essentially this times 4, because you have for each color you have 4 bits, size of 4 bytes, right? So 4 times unsigned integer 8 bit. So get a value for a red between 0 and 255, and the same one for green and blue. And because we're having a texture, we're also having alpha, although we're always going to set a default to 1, because there's no reason to do alpha in a texture where there's no alpha. Okay. So we want to get a pointer to our where we will write our data. So for this destination, and we want to reinterpretCast this one. The reason we're using InterpretCast is simply because we don't want the compiler to modify any data right now, because we're gonna write to this destination. There's no need to modify anything, manipulate anything. Lock texture to D. This will essentially lock the memory away from the game and other threads, so that nothing will access this while we're doing anything. Nothing. This will prevent essentially crashing. Okay, so we'll put our texture archi in here. Then MIP level 0. The next thing will be our mode. Will be write only. And then the dest stride. And also we do not want to lock within map tail. A MIP tail. And we also don't want to flush the archi thread. Yes. Again, they call it dest stride, but it's, once again, it's essentially your line width in pixels times 4, in our case at least. So if you might have a, let's say you have an HDR screen with 10-bit pixels, then maybe this will be different than what I have with an 8-bit. Like with 8 bits per color, per pixel. Okay, so now we want to iterate through our pixels, our colors. So height is 0, and then we're going to loop until height is smaller than viewport size. For the Y, we're going through height. We're going to see in a second why we start with height. And then height plus plus. Okay, so let's pointer to destination. Equals destination. This is a pointer to an array of many event dates, right? So in our case, the one we target is size dot viewport size dot y minus 1 and minus height. So essentially what this will do is it will start from the bottom to the 0. And we're also going to multiply this by the dest stride. So this is essentially telling us that, let's say, we started line, I don't know, so this size sort of y to 160. However, we want to get our pixels where there is a we want to get the first pixel in the last row. So if we have like 160, we might be somewhere, I don't know, here at the very beginning of our screen. Due to one line being like 160 by 3840 by 4, we're just gonna say, okay, we want to get the last line on our screen. So we'll essentially offset it all the way down to here. Okay. And then we also want to make sure that we're getting our a pointer to our pixel width from the data, right? So from our, this is where we want to go, and this is where we are right now, right? So essentially the same game here. this case, we can call it source pointer and then equals from our pixels. And then it's almost the same name here. So viewport size dot y -1, so we don't overflow. Start at 0, right? Minus height and times viewport size dot x. Maybe there's some discrepancy within those two. I don't know, but we're just going to do it this way. Now we're going to go for each line. So this will be now our width. 0. Width smaller than viewport size dot x. And we're gonna increment width every iteration. So now it's just about time to write to our render target. So what we're gonna do is dereference the destination pointer, and then we're going to set its value. So this is the first one out of the 4 values, right? So we have our format set to R8, G8, B8, A8. So we'll start with red, which means that we go from the source pointer, C, and we're just gonna get the R, right? So we have RGBA, so you could also likely get it as a uint32, but this way we have more control. And then, since we're incrementing this pointer every turn, we're now at the next value, which will be RG, green. So, as you know, there's a... We could also do like ++ this pointer, right? However, this would increment the value and then return it. This one is first returning our value. So this is still the unchanged value and then change it after. This pointer ++ equals source pointer RG and B. And for alpha, so our format is with alpha as well. In our case, we're just gonna do the max value 255. And we're going also to increase our source pointer. So this will essentially go into the next array item within, to the next pixel in our line, right? So we've now set RGB and A. Comment the A. We're not completely done yet. We need to still unlock our memory once again. So RHI unlock texture 2D. And once again, derender target resource. And then once again, that we're at MIP level 0 or MIP index. And we do not want to lock or flush. Oh no, it's not the render target resource. No. The texture RHI. Right. Okay. Now we can go outside of our. This is essentially the end of render command. I think we. Okay. And then we want to tell our render target to update its resource immediate, and we do not want to clear it once we just written to it. Now we can also empty our pixels array, although should be also automatically done since this is not heap memory. Okay. If we hit compile now, everything should work out just fine. And what we should be able to do, just should be able to specify button. So we'll just do view, or you can do whatever button you want, or whatever way you want. Oh, nope. There, like key. Gamepad, keyboard events. Where's the U? Well, let's do P. So on pressed, we want to do our screen. How did we call the function? Screen to render target. Did we even compile? Or like reload? Well, we might just wanna restart the engine. Do a clean restart. Okay. Screen to render target. There we are. We also want to specify render target. Yeah, what we can do now is let's get a plane. And create a new serial from our render target. So we can see what we just did. You might want to make it somewhat the size of your screen, or at least the aspect. Otherwise it will be stretched. Okay, there's a lot of sound. Okay, and hit E. Now, as you can see, I think it is upside down. Probably should be this way. Am I right? Yeah, the X should be our width and the Y will be our height. Okay, so that's why it was a bit. So I just hit P, and well, the blurriness, if you have it blurred, will also be there, but if it's clean, it's just as clean as here. So as you can see, there's the rust texture, I don't know, steel, chrome, some other steel, gold. Essentially this piece here. If we hit P, should also see the reflections, and everything should be within there as well. Yeah, there they are, the reflections. Yeah. It will also capture all of your, essentially everything that you see on screen, right? Aside from UI and stuff. You will see, so also the particle effects, the lighting, and everything should be as you see it. The sea seems a bit darker on the sky. If I like this one, it looks a bit darker than what I see on my screen at least. And the auto exposure is also doing its job. So yeah, as you can see, it didn't update within here right now, but the if you open it up, the picture, the thumbnail will update. Keep in mind that if you set this, if you change this format, then it will essentially clear the render target, and if you do any settings within there, it will once again clear the render target, and your green data all gonna be gone. What you, however, could do is also then there's a PNG image wrapper. with which you should be able to like compress and decompress. And then you could, for example, just compress it to PNG or JPEG, and then either like send it over a network or save it in a folder for screenshots, or like compress it in with a gzip or clip, save it in binary format. You can do whatever you want with this. And yeah, so I may make a tutorial on how to send this data over network soon as well. That's it for now, and see you then next time.